Good afternoon, everyone. I hope you guys are enjoying the sessions over here. My name is Rahul Karnik. I have George Philippakos with me and Brendan Monahan. And we're from St. John's University, which is in Queens, New York. We have roughly 19,000 students and a small IT shop. So roughly 15 years back, we migrated our student email system to the cloud, and that was our first introduction towards the cloud. But for 10 years, we never considered cloud as an option for any of our projects. 5 years back, our new CIO, Ann Pachion, took over, and we really started discussing cloud as an option or an extension to our data center. And we started looking at different projects which were in our pipeline. And we realized that we had a big project, which was Banner Upgrade, which was slotted for a year from then. And we said that the amount of fault tolerance, high availability options, what we were looking for all those on-prem will need a decent amount of hardware. So we really started looking at cloud as an option. We knew our IT team was really small and limited knowledge about the cloud. So what we did was we formed a small team first and as a working team, and we realized that really we were lacking on a lot of knowledge what was needed and expertise which was needed. So those were our weaknesses, but with the help of AWS support teams, slowly and steadily, we started converting those weaknesses into our strength. And thanks to AWS for that. They gave us full understanding of what kind of support structure we'll be getting, and same exact support we got it before migration, during migration, and after migration, which was key for us. We also wanted to have QA, test, dev, as well as the production environments, which we never had on-prem previously. So when we were looking for a cloud, we wanted proven solution. We didn't want any pressure from the sales teams, and assistance in design and implementation, which was the key. At this point, I will have George come over and go over our infrastructure.
Hi, everyone. Welcome. I just want to give an attempt to introduce to you how we did our baby steps into the cloud with a little bit of an introduction to our architecture. As Raul mentioned, we were a very small team. As a matter of fact, you're probably looking at the only person in the team to work on this at the moment. But we knew we had to start simple. So what we did is we started a single AWS account with a multi-VPC strategy. So in order to accomplish our enterprise application migration, we created 5 VPCs, our production, test, QA, dev, and as well as toolbox. In order to accomplish our high availability and fault tolerance requirement, we utilize availability zones. So we distributed our systems across 2 availability zones, and using our network and the subnetting, we were able to create that separation. And also a security boundary, and we manage everything via the use of security groups instead of complicated firewall appliances. Another thing that we didn't consider at the beginning was deploying all these as infrastructure as code. And with the help from AWS support team, we were able to develop several templates and deploy all of this infrastructure using simple code in CloudFormation. Lastly, as probably newcomers into the cloud, the latency was kind of a concern. We were not sure if it's going to behave the same way as we were used to traditionally in the data center. So we ran a few latency tests, and surely enough, the cloud was even more performant than what we expected from an on-prem. This is a brief illustration of what our environment looks like today. So you see our 4 VPCs which host our EC2 instances, but in the center you'll find the Toolbox VPC, which is we created that to host all of our shared resources as a good practice. So all of our domain controllers, backup appliances, scanners are all hosted in a one VPC. And what you can see from the illustration, all of our other VPCs are peered into that Toolbox VPC to make use of, consume the resources stored in that VPC. One thing I did not mention, we initially started with a VPN, but quickly we onboarded with Direct Connect. So our main pipeline right now is Direct Connect, and we use a VPN. We still held the VPN for backup purposes. The next logical step after we created the infrastructure was, okay, what are we deploying, right? So initially, the next logical thing is to deploy EC2 instances. Now, we had a lot of questions, and one of the biggest challenges was to break away from the on-prem culture of over-provisioning. So we got used to definitely buying oversized servers for several purposes. Again, I wanted to mention, with the help of AWS support team, we went through our EC2 analysis, we went through our recommendations for our application, and we were able to properly, semi-properly, as to say, size our instances and our deployments, look at our storage. Again, we did over-provision, but it's work in progress. We are looking into these things for the future to slim it down as much as possible. And one more thing, we initially started with reserved instances, but slowly we realized that it was more flexible for us to get into savings plan. And as a matter of fact, utilizing saving plans, we were able to save about 30 to 40% in our monthly bill, which was great. Again, for fault tolerance and high availability, we utilize the target groups and the application load balancer to accomplish our goal. And once again, we were able to deploy all of our EC2 instances using IaaS, CloudFormation scripts, which was a great saving time for myself. A little bit more about infrastructure as a service. Myself, I was a little, it appeared a little complicated at the beginning, but again, the support team was working very closely with us to develop based on our needs. And what the end result was that we were able to reduce the deployment time by minutes. So instead of me going into the console and deploying like I would normally do in an on-prem environment, just a click of a button and my infrastructure or my EC2 instances were deployed. Also, we wanted to maintain some level of consistency. Versions, application versions, and all that was accomplished by creating also, along with a CloudFormation script, a bootstrap process where we deployed our Tomcat instances and any other application or utilities needed for the application to run successfully. Once we had deployed enough infrastructure and EC2 instances, we were looking to see how we can monitor, manage, and possibly automate some of our processes. So we looked at a lot of third-party tools in comparison to AWS tools, and we determined that AWS tools were sufficient enough for our implementations to manage and monitor our environment. And some of these tools are listed here. I'm sure many of you are familiar: CloudTrail, CloudWatch, Systems Manager, Macie for our S3 monitoring, Flow Logs. And we extensively use DataSync to do file transfers between our on-prem servers and AWS. Once we had essentially almost all of our environment in AWS, I think our ERP system at the moment is at 98% running in the cloud. Disaster recovery was the next big logical step, and in today's world, it's probably one of the most important. We were looking at different solutions. We came in contact with AWS support, and they introduced us to Cloud Endure, which for me is like the best thing after the wheels. So we were able to quickly reuse our IaaS CloudFormation scripts that we used initially to deploy our infrastructure and deploy a new data center, in quotes, over in our US West side. And using Cloud Endure, we were able to quickly deploy an agent and start replicating our servers across the country in a heartbeat. Now, we did run a few DR tests. And I can tell you right now that it was a single-click deployment, and it reduced the DR testing from days to minutes. It's an incredible tool. And lastly, I want to go over, because I know everybody's mind is going into a cost and monthly running costs. Based on our infrastructure and our deployment, the 4 key optimization lessons that we learned is definitely look at your EC2 sizing. Take advantage of the enhancements that AWS comes out with every month. Look at the new instances that they release. You might be able to get a new system, more performance system, for cheaper these days. EBS volumes. We were initially started with GP2, then they released GP3, which it's highly more performant, as well as you save about, don't quote me, 20%, I believe, over the GP2. Also, the savings plan, which I mentioned earlier, it's worth taking a look on how you can reduce a monthly bill by purchasing upfront savings plans. It's definitely helpful. And last but not least, ensure that you use the consumption model that AWS offers you. Everything is pay as you go. So power off the servers that you don't need on the times that you don't need them. As a matter of fact, our environment, the dev, QA, test environments, which I only utilize during business hours, we power them off at the end of the night. And that's what I have to say. Brendan?
Thank you, George.
Thank you.
Good afternoon, everybody. So this is life before DevOps at St. John's University. I'm sure some of you can relate to this. So before we adopted AWS DevOps policies and procedures, this is about 3 or 4 years ago, we had no clear separation of duties between developers and the DBA team. This led to reasons where the production environment was not locked down and secure. We had a lot of developers who had access to production, a big taboo, and we also had some of the business users who would actually run shell scripts on our production environment. There was no version control or easy way to roll back prior code releases. The method that we used 4 years ago, somebody would send an email with an attached file for source code, say, please install this in production, or they'd say, point you to a development server and say, hey, my file's here, can you move that? And of course, this is seriously error-prone and just not best practices. We had a test environment that wasn't exactly the same as production. This resulted in lack of confidence in our testing. We had situations where you would test an application, and all of a sudden there were no problems. You move it to production, and you start getting people calling up, this isn't working, that's not working, and that's solely due to the fact that your testing environment is not even close to your production environment. We had a manual release process to production, which is prone to errors. We had a request for on-demand copy of production environment that required multiple script executions. So even if we wanted to sync our production environment back to our test environment, there was about a 15-step procedure, and it just was very manual and difficult to do. And of course, annual audits resulted in clear violations of best practices for software development lifecycle. So DevOps, finally, when we implemented DevOps. What is DevOps? It's a combination of cultural philosophies, practices and tools that enable organizations to deliver applications and services at high velocity. And this diagram kind of sums up, I think, what DevOps really is. You have your pipeline, which is the build, test, and release to your customers. But the important part is the feedback loop, which you're constantly trying to improve the process. You're looking for ways to be more efficient and improve the whole way that you deliver to your customers. This is a good diagram because you see these terms in DevOps all the time, CI, CD, and it can get confusing at times. So continuous integration is a process whereby the developers are pushing their code changes to a repository frequently, as often as they can. And continuous delivery will build upon that. When you push through a repository, it actually prepares the source code to be built and pushed and ready for a release to production. With continuous delivery, you have a stop point in the delivery pipeline where you have to have the testers go and test some applications, and then once they're done, or the business might have to test the application. Once they completed that, you get an approval, and then you do a release to production. So the only difference between continuous deployment and continuous delivery is the fact that with deployment, you're going straight to production. You're not even having a stop point or an automated approval. And obviously, inherently, because you're doing that, you have automated testing built into your delivery pipeline. There are tools out there like Selenium that we looked at to try to do this ourselves. It's a goal we have, but we are at the point at St. John's of being a continuous delivery type of setup for DevOps. So these are some of the tools that we used, AWS tools and others. Code Commit is a scalable, basically repository for private Git repositories. It's an area within AWS that is a managed service, so you do not have to have any infrastructure deployed. You're basically just using a console. You're setting up your repository, and it's similar to GitHub. It's a really easy tool to work with. Then we have something called Code Pipeline. This is where you build your pipelines. You could look at this. It's a modeling and visualization tool. And what it allows a developer to do is to connect your source and targets in kind of a workflow setup where you're going from your code commit repository to deploying your source code files onto application servers, et cetera. So you set up a whole chain and link them together, and it's very visual. It's a really, really good tool. Code deploy is where you define what are you going to deploy to. So that could be an EC2 instance. It could be an on-premise server. You could deploy to Lambda, Fargate. There's a lot of options in what you could do there. Code build is exactly what it sounds like. Code build is basically for compiling your code, whether you have C modules or whatever it might be. We actually use Jenkins because we already have that product installed. That is a CI/CD tool. It's open source. And we have that for some of the Banner ERP system that we do upgrades on. We use Jenkins. So we tapped into that to do compilations. And what we do in our delivery pipeline is we push the changes to our QA and prod environment, and when they get there, and most of our developers are working with SQL files, so it's Oracle database, procedural code, packages, procedures, functions. We have Jenkins do an automatic compile into those environments when the files get pushed to the servers. And this way we're eliminating the DBA from actually doing anything. Everything is in a straight pipeline. Some helpful hints. Practice restoring older versions of a file. Your developers are definitely gonna mess up and say, I need 2 versions back, 1 version back. You have to be able to run your git restore commands or teach them to do it. Also practice restore an entire directory on the application servers. So once you set up code commit, all of your files are there. So even if you're deploying the source code to multiple servers, it's very easy to just push those from your repository back to those servers. So if something gets corrupted or your file system seems a little bit awry, very easy to practice restoring from your repository back to your servers. This diagram, it always makes me laugh because there's a lot going on in here, but I'll try to bring out the key points that I think are important, which is we basically have defined 2 pipelines, and our first pipeline goes all the way from our development environment to QA. And you can see how we're doing our installs in the QA environment in Jenkins, and you can see how we are continuous delivery because our release manager, there'll be a stop before we go to QA, there's an approval process, et cetera. There's also another stop point and approval process to production. So this is the whole flow. The first pipeline all the way from development code commit to QA. The second is basically our install into production. So this is the flow of how we designed our pipelines. And the important thing here is to really talk about branches, because if you've ever worked with Git before, the common branches you have are the development branch, and you have a master branch. And development is for developers to work on their source code. The master branch is usually a copy of your production environment. There's a lot of AWS documentation out there that's really good. We use a third branch called a release branch, and this is also sometimes referred to as a feature branch. This branch is used to basically pull the changes when we make installs to prod. You take the development branch changes for the source files that you need, you basically bring those over to the release branch, which is a copy of your production branch. It's the same code. So when you bring in a file into the release branch, you do a merge, and basically you can see the differences, and you get that file, and then it pushes it to prod, and then you install the code that way. As I said before, the QA and the prod, this is where we're using Jenkins and doing the automatic compiles on the fly. Some lessons learned. Culture, you had to get buy-in from the development team and the managers. It's critical for success. I had to spend a lot of time training development teams how to use Git, how to log into the AWS console and do clones of the environment, of the repo, the code commit repo, back down to their desktop, things of that nature. Partners, AWS is great for setting you up at best practices and how to architect this correctly. Some great documentation out there for the branch design as well. That's an important part of this. And this is where we are now. Our staff situation, as Rahul said, we're a small team, but we do have a DevOps-focused team, and we now have a cloud services team that is building. It's not just George, we're getting there. We're getting more people. We've become more confident with our cloud technologies, more agile. We're more secure, DR-enabled with Cloud Endure, scalable and fault tolerant. We've embraced infrastructure as a service, using CloudFormation. We've automated as much as possible. This is something I preach to my team all the time. It's really important, just the manual steps that you see people do. I always pull somebody in, I'm like, you can do this better. Operational status, we have clear roles, responsibilities, and access rights. We've become more confident in our test and release process because we know that when we do a test in our test environment, before it goes to prod, I could identify everything that's different in my test environment now and what's in my prod environment. And it's just in-flight changes. It's nothing significant. They are pretty identical. So our future plans are to incorporate automated testing, possibly into our pipeline. That would be nice to have. We're definitely confident in our test and release process at this point. And we are now looking at our Banner ERP system. We are considering using some new technologies. We're looking at Docker. So we're looking at Amazon Elastic Container Registry, which is pretty much the same thing as Code Commit, but a repository for your Docker images now instead of source code files. And we're looking at ECS as well. That concludes the presentation. Does anybody have any questions? I think we have some time. Yes. We use Oracle as a database. That is correct, yes.
Enterprise?
I'm sorry?
Enterprise or?
Enterprise. We use the Enterprise edition, yes.
Do you consider RDS?
We would consider RDS. It's a really good question. These guys were trying to push me to RDS, and I would have used that as a solution, except that the Banner product, the vendor, they put their business logic inside of the database. So a lot of the procedural code and package code is inside the database, and we would need access to that because we customize it. So we really need to have control of that system. We couldn't really use it as a kind of RDS kind of setup, which is more where you can't log into the servers and look at anything. So we did consider it, though.
RDS Custom might make sense. I'm not sure if you're familiar. It's a new one that's going to be able to do that.
Yeah.
I have a yellow one. I'm going to reach out to you guys.
Okay. You think RDS would work first, is what you're saying. Well, what Ellucian has done, they've actually moved the product. They were tightly tied to Oracle, and now they went to Postgres. And what they're trying to do, their big push now is like everybody's software as a service, right? So they're trying to get all of the clients who are using their systems to go to their SaaS model, and they're beefing up the price for that. So that's a big push, and you'd be happy to know they're in AWS as well.
No, that part I know. They are on our ed tech division.
Right.
I'm on higher ed for
Okay.
databases. That's the reason.
Yeah.
I was
Okay.
curious.
Thanks. Any other questions? All right, thank you.
All right, thank you so much to Brendan, George, and Rahul. Oh, another question? Oh.
when you tested your DR failover, like completely to the West Coast, did you ever test that as a live test with your 19,000 students actually accessing production on the other coast?
What we did was we actually tested it with our test environment.
Okay.
We haven't done it with the production, which we're scheduling
Okay.
soon, but it's exactly same as our production. So we moved our test system over there and did the testing internally, not from a student perspective.
Yeah, it makes sense. I'm just curious about the latency. I'm just curious if you think the latency would increase or actually impact the student.
We did not
I have a
see-
similar question.
We did not see a lot of latency difference from our east side because most of our application servers are now also in AWS. Very few which are front end to the banner, which are still on-prem. So latency-wise, we did not see even hitting the websites
Yeah,
or
okay.
we did not
Yeah.
see it.
So on-prem into AWS, no negative impact, maybe
no,
positive
no.
impact for latency. Yeah.
At least from the test
Yeah, yeah.
systems, we did not. Now, we did not do a load test. Okay, that one we did not.
Yeah, sure. Okay, yeah, I was just curious. Okay, thank you.
You're welcome.
Thank you.